We've been working to put censorship resistance on a firm empirical footing. What we're doing here is looking at censorship resistance through the lens of network measurement. And today I'm going to be talking about opportunities that arise when computer scientists work together with political scientists to solve these problems, as well as some of the interesting technical challenges we've come across and solved in our work. So when we talk about censorship resistance, you can think of this as a standard security problem, except our adversary has different goals and motives. So many of you are probably familiar with the standard model. We've got our fly-by-night spammer. He sends out a bunch of fake Rolex ads, hopes some people will click on these, and he gains some revenue. And when we're talking about censorship resistance, what we're actually dealing with is an adversary who's willing to put in a lot of time and financial resources in order to achieve their goals. So here the goal is to restrict access to information, or maybe to gain access to information about different groups within their country that are performing political opposition. So they want to know who's organizing the protests, which groups of citizens are rallying, and these sorts of things. Since politically motivated actors are willing to expend considerable resources, there's become a huge market for censorship and surveillance products. Many of you people are probably familiar with the logos on the slide here, and these are many products that are actually developed by companies in Western countries. So WebSense and SmartFilter are American companies, and Netsweeper is actually a Canadian company from down the highway from where I did my PhD. So, hometown company. And the challenge here is that we've got products that are developed by companies in Western countries being used around the world to violate human rights. They're used for censorship, surveillance, and to restrict people's ability to speak freely on the internet. What we're doing about this in my lab is we're taking a collaborative approach. We work with political scientists who reveal interesting local contexts and cases that we can measure around the world, and we design new network measurement techniques that allow us to better understand where censorship is happening, as well as how it's actually being implemented. At the heart of our work has been the ICLab project, which is a global ongoing monitor to monitor internet censorship around the world. As part of this, we're developing new techniques to detect internet censorship, as well as methods for fingerprinting different devices. So we don't just want to know that a URL is blocked. We want to be able to say specifically how is it being blocked, and is it being blocked using a specific product. So before I dive into the technical part of my talk, I just want to set the stage and motivate why we think measurement is the right approach here. And this came up in one of the conversations over lunch a couple days ago, this idea that shedding light on internet filtering can actually change behavior. And I want to share a historical example that I think really captures this idea well. So after World War II, there was radio signals basically transmitting from Western Europe into Eastern Europe. These countries didn't like that, so they implemented radio signal jamming. The ITU came and put regulations in place saying, don't block these radio signals, but the radio jamming kept happening. So what the ITU did was implement an ongoing monitoring program with the idea that this data could be used to directly pressure these countries to stop radio signal jamming. And the interesting thing about this example is that as soon as these reports were made public, they didn't actually have to put pressure on these countries at all. Just publishing these reports caused these countries to dramatically scale back the radio jamming. And that's what we're trying to do here by monitoring internet censorship. So there's real value in terms of having a baseline out there that we can sort of look at and put this sort of indirect pressure on countries to change their behavior. When we talk about measuring internet censorship, we might perform an experiment like what you see on the slide here. So we might access CNN from our lab at the University of Massachusetts, and then we'll try to access CNN from a network where we suspect filtering is happening. So this might be Yemen, Burma, China, pick your favorite censoring country. So we've got the results of this experiment, and the standard question is, well, is this website being blocked? Obviously, looking at the results on the slide here, page says access denied. We can conclude that it's being blocked. However, what happens if we have this case? So we've gotten CNN back in our lab setting, but in Yemen or China or wherever we're doing our test, we get no HTML content back. How do we know what's going on? Is this being blocked? Is this a network outage? Did the person not configure their wireless access point properly? How can we actually know what's going on? So in order to understand these cases where sensors might not be explicit about their blocking, they might not come out and tell you that they're performing blocking, we need finer grained measurements. We need to look at our DNS replies, we need to look at packet captures to see injected TCP reset packets, and so on. And we're also going beyond the standard questions that political scientists have been asking. We don't just want to know if a website is blocked or not, we want to know how is it being blocked. Is it using DNS, TCP resets? Can we use this as input to different evasion techniques? We want to know, is this a product that's under sanction and shouldn't actually be employed in this country? As well as who's doing the blocking. Is this the person's ISP? Is this blocking by the content provider against users from a certain country? Is this accidental transit filtering? These are all sorts of more detailed questions that we're trying to answer with our work. So what this means for our ICLab platform is that we need to support the basics. So your standard HTTP GET request, see if you can get your HTML page, but also the not so basic. I've got one example on the slide here where we'll set our HTTP header for content length to have this sort of strange capitalization, and we send a request to our own server. And if it comes to our server and content length is suddenly all uppercase or all lowercase, we know that there's a middle box sitting on our path that's actually reading in our headers and rewriting them out before sending them on. We also want even less basic items, so maybe we want to start a TCP connection and then start changing our IP TTL values so our packet doesn't make it all the way to the server and see what happens. And these are all different things that we want to enable so that we can understand where in the network censorship is taking place. So it's really the sort of interesting cross-layer measurements that we're doing. And finally, we don't know the complete set of measurements a priori. New censorship techniques can come about. We might hear about different forms of filtering. And we wanted a way to sort of customize and extend experiments over time. To give you guys an overview of what our system looks like, we've got our control server at the University of Massachusetts. So this is sending experiments, so telling it to go fetch a bunch of web pages, relevant data, so this might be the list of URLs to test. And it's sending this to our collection of vantage points. These vantage points are VPN nodes in tens of countries around the world, as well as a handful of Raspberry Pis. And once the client has done the experiment, it's going to send the results back to the control server. One important thing to note here is that we've tried to keep these clients as simple as possible. So this is in contrast to some other censorship measurement approaches. And the idea here is that we want to do the bulk of the analysis back at our server. So if we want to reanalyze data or we want to go back, analyze the previous year's worth of data, we have the data there and we can do this. So the data comes back, we put it in our database, and then we run different sorts of data analysis code. So we might do block page detection. Surprisingly, this was not a solved problem when we started working on this, figuring out that you actually couldn't access the web page automatically. Also fingerprinting specifically which censorship product is being used. And then these results and analysis are output and produce web pages, white papers, peer-reviewed reports about our findings, and so on. Okay, so this is sort of a high-level view of ICLab. And obviously, there's some challenges here. If any of you guys have played around with network measurement, you know that what we want to measure and what we can measure are usually two different things. Well, censorship makes it even harder. You're trying to measure something that might try to hide from you, or something that might actually try to tamper with your measurement platform. So an important thing that we do is authentication. So the client and server communicate using HTTPS, and they authenticate within the connection. And one thing we haven't had to deal with yet, but that's definitely on our radar, is what happens if the censor suddenly blocks access to our control server. We can't send experiments out to the clients can't send results back. This would be no good. We also need to distinguish failures from filtering, so looking at packet captures to see injected reset packets, and having the ability to correlate between multiple clients. So are we seeing a bunch of events with clients in a given subnet? Are we seeing events across clients in a given country, and so on. Also, getting access to vantage points in this case is a challenge. So we want access to vantage points in a variety of regions. And in the cases where we have volunteers on the ground helping us, we have to worry about their safety. So there are countries where, if you're seen performing these sorts of measurements, you might get a knock on your door from possibly an angry government official. Okay. So here we've got the map showing our current ICLab vantage points. The green nodes there are a handful of Raspberry Pis that volunteers are running. And the red nodes, which are the bulk of our vantage points, are actually gained from different VPN providers. So this allows us to get wide coverage without actually putting people at risk. So this has been sort of a nice trade-off in terms of being able to gather a wide range of data. Okay, as I wrap up, I just want to talk about two cases where ICLab has actually been useful in terms of investigating censorship around the world. The first case was in 2015 during the Yemen conflict, and this was with the Citizen Lab. If you recall, I talked about these filtering products on the earlier slides, and these are dual-use technologies. I believe the first talk in our session talked about schools using these to keep kids away from inappropriate content. But we're looking at the cases where they're installed in national backbone ISPs and being used to restrict access to free information and content that people should be able to access. This obviously hasn't gone unnoticed, so the White House, with President Obama, put sanctions in place saying that we shouldn't export these products to Syria and Iran. The EU had similar restrictions put in place. And a big question is, how do we even enforce this? How do we know that it's Netsweeper or Blue Coat being used in a given country? And this was the challenge that the Citizen Lab brought to us in this case. So here they had this block page that they were seeing in Yemen. If you squint, you can probably read the URL there. It's playboy.com. And they're getting a block page saying, no, you can't access playboy.com. Fairly straightforward. But for this other website, which was actually political content, they weren't seeing a block page. What they were seeing is an HTTP 404. And so they come to us and they say, is this HTTP 404 message blocking? What is this? Is this Netsweeper? Can we say anything about it? And so here we got to do our fun network measurement stuff, trying to figure out if this HTTP 404 is actually coming from that Netsweeper device. And here we use probably one of my favorite IP headers, IP TTL. If you remember from your undergrad networking, this header is set at the end host, decremented at each hop along your path. When it hits 0, your packet gets dropped. So avoiding loops in the network, good for that, also good for measurement. So how we're going to use the IP TTL to detect an injected packet is as follows. Our client is going to send their TCP SYN packet to the server. The server is going to reply. So you see there the server has set the TTL to 128. When it creates its packet, this value gets decremented, and the client sees a TTL of 48 in this case. Okay, so the client sends their acknowledgement. Maybe they include their HTTP GET, and they send this to the server. And what happens is, if the censor sees this GET request and it wants to perform filtering, they're going to inject their block page or their HTTP 404 page, and this is going to arrive at the client. So now what our client can do is actually compare that TTL value between the SYN-ACK packet and this HTTP 404 page or the block page. So here are the results from Yemen. So the graph on the left shows the TTL on our HTTP 404 page. The right shows for the block page. I've also put the TTL that we had on our SYN-ACK packets there as a reference. And handy for us, it was basically exactly the same TTL value being used on the block page as well as on these HTTP 404 pages. And based on this, we were able to say that this 404 message is likely coming from Netsweeper, and the censor is open about blocking some content, but other content, they're trying to be more stealthy. They're showing you an HTTP 404 page, which most citizens won't actually realize is censorship. They'll just think the site is down or blocking them. Okay, so this was a case where network measurement allowed us to see that filtering was happening even when the censor was not being open about it. Okay, I'll talk briefly about a second case. So this was some work we did with a group called Small Media in the UK, and they were interested in looking at filtering in Iran. And one of the things they were specifically interested in were tech sanctions. So they said, there's all these sanctions against, US companies shipping products to Iran. What does this mean for people's ability to access the internet? So we've got a table here, basically the set of URLs they wanted us to look at. We had 4 virtual private servers in the country. And it was interesting because what they sort of expected to see was a lot of local censorship. They said, hey, sanctions are in place, the government will be mad, they'll perform blocking. And so here the red shows that, yes, what we expected, some of this content is being blocked by the national telco in Iran. So here the things that we're seeing blocked are Flash Player, Netflix, Bitbucket, different content providing services. But we don't just see the local ISP doing blocking. We also see cases of server-side blocking. So here we're seeing blocking by Google, so Google developer sites, analytics, Android. And what we could see when we tried to access these sites from Iran was a page like this. So HTTP 403, basically saying you don't have permission to access this site. And this appears to be Google trying to enforce some of these sanctions when they see clients that appear to be coming from Iran. One important thing this work also highlighted, though, is sort of how difficult measuring internet censorship is. Things are not consistent. So we also saw, no blocking of GitHub, AWS, Azure, Dropbox. These were easily accessible. Google Code Jam, for some reason, was available, while other Google services weren't. We don't have a really good explanation for that. Also, even within Iran, we're seeing a variety of blocking behaviors. So here, we've got Flash Player that's blocked on some vantage points and not others. Same thing with Netflix, and it's not even the same vantage points. So this really highlights the importance of having not just vantage points in each country, but within each country having as many vantage points in as many different networks as possible, so we can actually figure out what's going on. So with that, I will wrap up. So what we've been doing in this work is showing how network measurement can actually reveal and give us a more deep understanding of internet censorship around the world. This is important because we're able to identify censorship when it's not necessarily out in the open. So if it's something that's more stealthy than just giving you a block page. And we're able to do this at scale and over a long period of time. We've also solved a bunch of interesting network measurement problems, which for me is sort of fun, looking at different filtering products, trying to distinguish censorship from failures, so looking at packet injectors, and dealing with these challenges of how can we actually measure when the thing that we're trying to measure might try to hide from us. And with ICLab, what we're really doing is we're closing the loop. We're not just taking a purely technical approach, we're actually working with social scientists who are aware of these situations around the world and trying to get a better sense of what measurements make sense, where should we be measuring, what's interesting and useful to measure. And as a result of this, we're revealing new interesting technical problems. So with that, I will wrap up and take any questions.